Hello everyone, now let's solve one numerical example related with stochastic gradient descent in linear regression. Here x and y are the datasets, and here first we have to calculate the simple linear regression equation, that is y hat equals to w0 plus w1 into x to get the predicted value, and after that we have to calculate the error function or the cost function, which is achieved by the difference from actual value minus the predicted value, and after that we update the weights w0 and w1 from this formula. W0 equals to w0 plus learning rate into error, and w1 equals to w1 plus learning rate into error into x. And for that, we w0 as an intercept and w1 as a slope, we initially assume this as 0 and the learning rate 0.01 throughout the epoch. Let's calculate the predicted value for the first iteration, which is calculated as w0 plus w1 into x. Similarly, then we calculate the error by the actual value minus predicted value, and then we update the weight w0 as w0 plus learning rate into error, and then we calculate w1 as w1 plus learning rate into error into x, and then we update the weight here 0.03 0.03. For the second iteration, we perform the same. w0 plus w1 into x, and error as actual value minus predicted value, and w0 plus learning rate into error, and w1 equals to w1 plus learning rate into error into x. After the completion of second iteration, we update w0 and w1 from the second iteration, and calculate the third iteration accordingly. Y hat equals to w0 plus w1 into x. Calculate the error as actual value minus predicted value. Update the weight w0 equals to w0 plus learning rate into error, and w1 equals to w1 plus learning rate into error into x. And after the completion of third iteration, we update the w0 and w1 from the third iteration and perform the fourth iteration. Y hat equals to w0 plus w1 into x, and error equals to actual value minus predicted value, and w0 equals to w0 plus learning rate into error, and w1 equals to w1 plus learning rate into error into x.